Hey guys, welcome back to the channel. Today we have an interesting topic to cover. It's about replication. Right? So you know that whenever you have more than one servers in your environment for a particular application, you would want to make sure that the data is synchronized between the two. The reason might be that you want to have high availability for automatic failover using max scale, or maybe you want to just simply have a DR environment where you can fail over to if the primary site goes down, right? So whatever the reason, you need replication setup between master and slave or primary replica. And there are times where you might see some sort of replication lag between the two servers. That lag can be for many reasons. Maybe your network is slow, or your disk IO is very slow, or even if you have very fast IO for using NVMe storage or SSD, fast SSD storages, or even persistent memory, you may still see replication lag, because the primary reason behind that is that the MariaDB server uses a single thread by default for replication, right? So the replication worker on the slave is basically using a single thread. So if your server or if your master node starts to push too much data to the slave, the single threads can only do so much, right? So you want to make sure that you configure multiple threads for your slave, so that those multiple threads can do magic in parallel, and then they apply multiple transactions on the slave at the same time. So that is when you will eliminate any replication lag, right? So but the problem is that it's not simple. It's not so simple that you just simply configure multiple threads for replication and then everything will be fine, bro. It's not that simple, right? So you need to take care of a few things before we do that. So that's exactly what we're going to discuss in this video today. Let's look at this document that I prepared in my GitHub repository. So again, it's public. I will be putting a link here in this video for you guys to review. So we are talking about parallel replication in this document, and what are the different modes of parallel replication: optimistic, aggressive, and conservative. We are going to be discussing conservative mode of replication here in this video, because that's probably the safest one out of all of the above. And then just take note of that if from MariaDB 10.5 onwards, optimistic is the default mode, right? So but I prefer conservative mode still, because optimistic mode can lead to some issues at some specific scenarios, for some specific scenarios. So that is why we don't want to go into that. So it's safer to stick with conservatives as of now, until this optimistic is thoroughly tested, and then it becomes more stable, right? Much more stable, and it can handle many different scenarios. So yeah, so just make sure that whenever you are using MariaDB server 10.5 or higher, just use this variable to configure your default parallel replication mode to conservative in your server.cnf file. So I have also embedded a link here that talks about parallel replication from MariaDB documentation, that will discuss all these three modes, what is the primary difference between the three, and which one to use when, right? So all those things are there. Just review that. And for our setup, we are going to be using one master and one slave, two node setup, very simple. And we are going to be using durable bin log setup, the sync bin log equals to 1, which is highly recommended for any production environment. And then the bin log format is raw. That is also highly recommended for best performance, right? The size may be slightly bigger for these bin logs, but this is certainly the fastest and the safest way to use, right? So bin log format equals to raw. Sync bin log should be set to 1 so that there's no data loss of any sort. And then relay log recovery is also enabled, which is also important at some typical scenarios. And the final important one is flushing log at transition commit is set to 1 also. So this is the most durable setup for MariaDB server, with ACID compliance, full ACID compliance, and full protection against any sort of data loss, right? So that this is the setting that we're going to go with. This one is important for for stability purposes, like when you stop a master node that is still busy replicating, so it will just make sure that the slave has received everything that they need before shutting down the master, right? So that's an important one for stability wise in the replication when you are stopping master nodes. But this parameter is only available for the enterprise version. So if you are unfortunately on a community version, you can't really use this. So yeah, so just take note of that. Then we are going to look at what exactly is parallel replication and how does it work. So I have also embedded another important link here. How do you calculate group commit ratios? So this is super important for conservative replication. So we are going to be using this the formulas and the methods defined in this particular link, how to calculate the group commit ratios. So why do we need group commit? Before that, to set up multiple threads on the slave or to enable parallel replication, what you need to do basically is just simply have this in your server.cnf, right? So slave parallel threads equal to a specific number, right? So, depending on how many CPUs do you have. So you would want to have enough number of parallel threads so that the parallel threads can apply those transactions that are coming in through the replication in parallel on the slave, so that they can catch up with the transaction load faster, right? But we can simply set it to 10 or 16 threads, but that might not be optimal value, and then we might be wasting a lot of threads for something that the server cannot really use. The reason behind that is that the MariaDB server by default is going to group some transactions, right? So for us to apply in parallel on the slave node, but that grouping may not be big enough, right? So that grouping may be 1, 2 or 3 or 4 transaction maximum, right? So it can be something like that, 2, 3 or 4 transaction at maximum. So if we set the slave threads to 10, it can and then your grouping that is happening on the master is only 2 transactions per group, then out of those 10 threads, only 2 threads will be really working, while the remaining 8 threads will be going to waste, right? So they are going to be sitting there and doing nothing. So that is something that you want to take note of. That is why this particular topic is so important, that we want to make sure that we calculate our groups carefully, and then we tune our group commit ratios so that we can maximize our threads, right? So we can maximize our thread. That's the basic idea behind calculating the group commit ratio. So if you look at the group commit part, what exactly is that? So for a given time frame, like for example starting with t0 to tn to a specific time frame, you are going to have multiple transactions that are coming into the server. So at T1 we have this transaction 1 committed, at T2 we have transaction 2 commit happening, and T3, T4 and then T5 we have a transaction commit happening again somewhere in the middle of these two. So these might be different threads from application clients. They are doing some commits, some transactions. So all of these transactions can potentially be grouped into a single commit group. And then on the slave node, if you have 5 threads available, then these 5 transactions, which are grouped into a single commit group, can be applied in parallel on the slave node. That is exactly what we want to achieve, right? So how do we achieve that? This behavior is basically, first of all, we want to calculate how many transactions per group are actually coming into our environment, right? So first of all, we want to see that. And then we want to do that on the master node, on the primary server. And then also we want to do that when your server is facing peak load time, right? So we want to prepare for peak load on your server. If your server is sitting idle, not doing anything, then this thing is actually useless. Meaning if you are doing this stuff there, then this is going to be useless. So you want to make sure that your server is hitting peak load at that time, and then you want to calculate the group commits at that time, right? And then we want to tune that group commit or group commit ratio on peak load so that we can have some realistic scenarios captured there, right? So the formula is basically we want to get a ratio between bill log commits. Those bill log commits are basically how many individual commits are happening for individual transactions, and also we want to calculate the ratio. We divide it by the binlock group commits. How many transactions are actually committed in a group? So we want to basically get a ratio. So we want to get two snapshots of this status variable in a sense like binlock commits and binlock group commits. So we want to get a snapshot, then we wait for 60 seconds, and then we run the same statement again and get a snapshot one more time, right? So then we'll get an output something like this, right? So we'll get for the first snapshot we'll get a binlock commits, binlock group commits. Then for the second snapshot we'll get the same two numbers again with different values, of course, because we are going to do that when the server is facing peak load time, right? So peak transactions are coming in. Then we are going to use the binlock commits from snapshot 2, the binlock commit this number from snapshot 2, and minus off from the binlock commits from snapshot 1. That's exactly what's showing here. Minus off from binlock commits from snapshot 1, and then divided by a binlock commits group commits from snapshot 2 minus of binlock group commits from snapshot 1. So what we are doing is basically we are saying out of the total binlock commits that are happening during that time frame, how many are being committed through the groups. So that will give us the transaction per group, right? So that's exactly what we're going to do. All right, so let's go back to our setup. So I have an environment here where I'm going to generate some load here on this master node here, and this is going to be my slave. So let's connect to the MariaDB server right now. So the number of slave threads and everything is 0 over here right now. So we can verify that. Global variables like parallel, I think it should be slave parallel or not. Slave parallel. Oops, this one, yeah. Okay. Yeah, so the slave threads and the slave worker thread is 0 currently, 0, which is a default value, which means that it's only going to be using one thread at a time. So if you do a show process list right now, we can see that there's only one IO thread and one SQL thread. So there are no multiple worker threads currently. So it's only one threaded process right now, right? All right. So what we're going to do now is we are going to start our load test. So we are going to start our load test to load generator to use 32 parallel threads on the master. Before we do that, let's take a look at show slave status. So as of now, our seconds behind master is 0 because there's no load coming in and everything looks good as of now. So there's no delay, of course, because there's no load at all. So let's run this guy. So it's going to start pumping some data to the master. Let's give it 10 seconds so that it can give us the first status report. So we can see how many transactions per second is happening. So we are having basically 1,400 plus or 1,400 plus transaction per second with 29,000 queries per second going on, which is quite nice. And then if you look at the slave status one more time, oops, there you go. So we can already see that the seconds behind master is already creeping up. Yeah, so it's constantly going up and never stopping, never going down. So this is something that every DBA will hate. Yeah, that nobody will like to see a slave lagging behind. All right, so what do we need to do now? Let's go back to our documentation here, this document page, and then I'm going to run this this guy, the full script that is going to run this show global status variable 2 times for these 2 variables, and then is going to sleep in between for 60 seconds. So we'll have a snapshot of 60 seconds duration, right? So let's, again, whatever we are doing now is going to be on the master node because master is where the grouping is happening. So let's paste it here and then run it. So let's wait for 60 seconds. All right, there you go. So we have 2 snapshots 60 seconds apart, right? So we have group commits and binlock commits from 2 sides. Let's use the formula. So I'm just going to use simple select statement to calculate the values. So the formula says that we want to get the snapshot the value from the second snapshot of bin log commits and put it here minus of the same variable but from snapshot 1. And so this is there, and then we divide this by the group commits from snapshot 2 minus the group commits from snapshot 1. So this basically tells us how many transactions are currently being grouped in a single commit group, right? So which can be applied in parallel. So as of now, we can say it's roughly 1.89, which leads to roughly around 2 transactions per commit group, which is not a lot, right? So that basically means that on this side, we should be able to set 2 slave threads on the slave side. I mean, so let's take a look at this variable name, slave parallel threads. This one, we are looking for this one. So we'll do a stop slave, and then we are going to set this value to 2. So if we set it to, let's say 12, right? So 10 or 12. So that's going to be a waste, right? So it's only going to be using that many number of threads which can accommodate these many parallel or group commits. So if we set it to a higher number, that is going to go to a waste. So it's not going to be any helpful, right? So that's the whole idea of this calculation. So what will work for this setup is 2 threads. 2 threads is going to work fine. And start slave. Let's see. Oops, there's something wrong. Set global, of course. Set global slave parallel threads equals to 2. All right, so it's done. So we are just setting up dynamically using set global command. But what you will have to do is you will have to set globally, set dynamically this value on your slave, and then also make sure that you put this value in your server.cnf file, so that next time when the server gets rebooted or restarted, it's still going to use the same number of threads, right? So that's an important thing to do. So, but to minimize the downtime, we can just simply set these 2 commands using dynamically using set global, which is good. So now we have 2 threads working. So if we do show process list, we can see indeed that there are 2 worker threads now, right? So previously there were no worker threads. Now there are 2 worker threads that are actually, both of them are doing something. This one is closing table, this one is running some delete statement, which is good. So at least we can see that the 2 threads are actually working in parallel, and then they are doing something. But if we look at the slave status, that should not have improved, right? So yeah, it I would say that it has improved a little bit, but the number is still increasing, but increasing a bit slowly, right? So it is still increasing, but it is increasing a bit slowly. So sometimes we will see that the number will come down, then it will increase again, which means that yeah. So yeah, you see from 20 to 19. So the previous one showed it was 220 seconds behind, and then this one shows 219, but eventually it's still increasing, right? So that's the bad part. So anyway, so now we know that our groups that are happening by default in MariaDB is currently 2 transactions per group. So how do we improve this situation, right? So that's what we're going to do now. So to do that, we actually need to look at two variables. So the bin log commit wait count and bin log commit wait usec. So these are the 2 variables that we want to do. We want to use basically. So if you look at the definition here, so I've already put good enough definition here. So this indicates the number of transactions that we want to group within a single commit group. So that's very clearly, this is the target that we want to achieve, right? So this is something that for our case, we want to have 10 transactions grouped in a single commit group. So that's why we are going to set it to 10. And that's what this statement is doing here. So we are setting this commit wait count to 10. And then the commit wait, the default is 0, of course. So which means that the server is not waiting for, it doesn't have any target. So it will try to group as many transactions as it can without any waiting. So that is why we have only 2 or 1 or 2 transactions coming into a single group. The second one, commit wait usec, is is actually the amount of time in microseconds that the server can delay the flushing of a committed transaction into binary logs. So this basically means that the server will wait for these many microseconds before flushing the data to the bin logs, or before flushing the committed transaction to the bin logs. But if this number is already achieved, meaning if the bin log commit wait count has already reached 10, then it will immediately terminate this timer. It will immediately terminate this particular timer, right? So that is the important one. So if you have a small enough number here, then the server will not have to wait for 10,000 microseconds, right? But if, let's say, you have a slow throughput coming in, then it will take a bit longer to reach 10 transactions in a group. So the server may end up waiting for 10,000 microseconds before flushing those datas into the bin logs, right? So flushing into the bin logs, and that eventually is going to slow down your transaction per second throughput of your primary server. So anyway, if your server is already slow in receiving the transaction from the application, then you are probably not even having a replication lag, right, in the first place. So you will probably not be bothered with any of this stuff. So you're a happy DBA, and then your database is running fine without any replication lag. But if you are one of those MariaDB DBAs who is facing a very heavily utilized MariaDB server, then the chances are that your server or your slave replication is lagging behind, and then that is why you will have to make sure that you configure these two things so that you can apply many more transactions in parallel on the slave node. All right, so let's go back to the server, and then I'm going to run these two things on the master. Again, remember that these things are supposed to be done on the master node only. So you're not going to be doing this on the slave ever. So just make sure. So that is why also important, don't put these values in the server.cnf file, right? So don't hardcode these values in your server configuration. So always use set global, always set these values dynamically, because if you hardcode these values on the server and then your master ending up becoming a slave after a failover, then your slave will also slow down because of you have these values there. So that is why it's super important to not set these values in the server.config file. Always set this dynamically only on the master node, right? So let's do that while the load is still running and the replication delay is going crazy, right? So it's already at 329 seconds. So I'm going to set this to 10, right? So we want 10 transactions at least in a group, and then later on we want to see 10 here or something similar to 10, and then we want the server to wait for 10,000 microseconds, because the default one is 100,000. The default is too long. We don't want that much. We want 10,000, right? So that's a standard I go with always, right? So always go with 10 and 10,000 as a starting point, and then tune these two numbers from that point onwards, right? So now we have already set these two up. Now we can immediately see that the transaction throughput has dropped slightly, right? So from 1499 plus, now we have dropped to 140, 141. So it has dropped slightly, but not drastic drop, right? Still we are seeing good transaction throughput, 1422 also. So that is why this particular setup seems good enough for my application right now. So I'm not seeing a drastic drop in transaction throughput, but the benefit is going to be very, very big, as we are going to see. Okay, so now that we have set these two values already on our server, I'm going to run the same statements again, because we want to calculate that transaction per group or transaction per commit group again one more time. So I'm going to copy this formula here, or this set of statements here, and then while the load is running, while the peak load is running on your master, so I'm going to run this statement again. All right. All right, there you go. So now we have an answer. We have two snapshots 60 seconds apart. We can now calculate the ratio one more time. But just one more note for you guys. This drop, the slight drop in transaction throughput, is actually only going to affect the writes, right? So insert, update, delete operations. but your queries or your select queries are not going to be impacted at all by this. So the server is just going to slow down just a little bit, but of course depending on your numbers that you put here, it may be a drastic drop, right? So just be careful on that. We are going to demo that later on as well, but yeah, for now, let's calculate that ratio again. How many transactions are we really getting now in a single commit group? Select. So the formula again is from the snapshot 2, we are going to get the bin log commits minus of the bin log commits from snapshot 1, and then divided by the bin log group commits from snapshot 2 and minus of the bin log group commits from snapshot 1. So again, it's just going to tell us how many transactions are appearing in individual group commits basically. Yeah, so let's do that. Okay, awesome. So this is exactly what I wanted to see. So we have roughly 9.88 transactions per commit group, which equates to roughly 10 transactions, right? So we can safely say that now we are basically having 10 transactions being grouped in a single commit group. So let's do that very quickly. So now I can happily set this number to 10 so that my 10 threads can apply those 10 transactions that are coming in into individual commit groups in parallel, right? So let's do that. All right, so it's done. So let's take a look at the slave status, see is there any difference. Okay, so the first thing that we see right away is that the seconds behind master is actually dropping now, which is a good sign, right? So which is exactly what we expected. So now it's applying multiple parallel transactions in parallel, as we can see. Show process list. Let's decrease the view slightly so that we can actually see what's going on. Yeah, so we can see that now multiple threads, multiple worker threads are actually doing work, right? As we can see here. Yep. Yeah, like so. So which is a good sign, which is exactly what we expected. And then as a result, we can clearly see that the transaction or the replication lag is actually dropping. So let's wait for it to drop to 0. So I'm going to pause this video and then we'll travel forward in time, and then I'll see you in a bit. All right, finally, the replication lag is gone. The server has catch up already. We can see that the transaction, of course, the traffic is still being generated. So there's no stop to that. The 32 threads are still working, running 28,000 plus queries per second on the master, and the slave is now no more seconds behind, right? So that's a good sign. But now let's stop this load here, and then I'm going to do something crazy. Let's put some crazy number here, like 64. Not 60. Oh, that's even crazier. I don't want to go there. So let's do 64 threads and then see how it goes. We should see a lot higher TPS now because, of course, we are running double threads compared to 32 threads. Yeah, that's indeed. So 2.6K transaction per second going on with 52,000 queries per second, right? So that's crazy. So now, is the slave still able to keep up with those 10 group transactions? Yes, indeed. So we can see that the slave and the IO, everything is running fine. And we should be able to see this GTID IO position should be moving because it's receiving data constantly. Yeah, it's indeed moving, but there is no replication lag at all, right? So that's exactly what I wanted to see, and that's exactly what's happening here. So I'm happy that with this particular setup with 10 threads running in parallel on the slave, we are still able to maintain that 26,000 or 2.6K transaction per second, we are still able to keep up with that. I am just curious what will happen if I go even beyond that. So 164, then let's say 128. Let's go there. This should increase the transaction per second even higher. Yeah, so it's 3.3K. Yeah, roughly 3K transaction per second with 60,000 queries per second running. Okay, so let's see if the server is still good. Okay, so now we see a slight lag of 1 second appearing here. Now this may be a little bit too much. So yes, so it's going a bit of lag here right now. So which means that our setup for those 10 threads was good enough for up to 64 threads, like 2.6K transaction per second. It was good enough. It was still able to keep up. But now we are seeing a slight lag of 1 to 2 seconds, which is still not very bad, not drastic. So as long as it stays within these limits, we should be good. So what do we need to do now? If let's say this is our scenario, very simple. We repeat the same process again. We run this statement again one more time, right? And yeah, we run this statement one more time. Not really this one, but we maybe increase this number a little bit more. Maybe we want to group 10 transactions out instead of 10 transactions. We want to group 12 transactions. Let's try to do that and then see whether how does that help. Yeah, so instead of 10, let's group 12 transactions in a group. Okay, so it's happening. So is there any change here? No, there's no change here. So which means that the time that we have defined, of course not, because our slave threads are still 10, right? So we need to increase it to 12 as well, because that's what we are targeting for 12 transactions. So let's increase that as well. So just to validate, we can again run the same statement now, just to make sure that how many transactions are we really grouping right now. But I am expecting that since we have given 12 here, so I'm expecting that we should be at least getting 11 plus transactions in a group. So let's set this up like so with the 12 threads and then verify the slave status. Okay, so that's a good sign. It's going down. Yeah. Let's see if we can go to 0. Okay, there you go. Yeah, so I think this is still acceptable, right? So we can still maybe increase 1 or 2 more threads just to make sure. But we don't want too much impact on the transaction per second here, right? So we can certainly do maybe 13 or 14 threads, let's say, and then set this to 14 as well. And then now it should remain at 0, right? So it should remain at 0 now. The seconds behind master should not grow up anymore. And then the impact on the transaction per second is still not drastic. So still we are still good. So we just to verify, we can again, of course, run this this thing one more time, just to make sure that our server is still able to still able to get those 13 or 14 transactions in a single group or not. Let's verify that. There you go. So I have already gotten the 2 snapshots and I've already calculated it for you guys so that you don't have to wait. So yes, indeed, we are roughly getting 13.67 transaction in a group, which translates to around 14 transactions, right? So on and off 14 transactions are coming into a single group, and that is that basically translates to this particular setup here. So 14 parallel threads, which is why we are sure that our server is able to run 14 parallel transactions in a on the slave side, and that is why even with that 30,000 transactions or 3,000 transactions per second, with 60,000 queries per second, we are still good on the replication side. Yeah. So yeah, so that's all there is for today. So I hope you guys enjoyed it and learned something new. May you guys never face any replication lag in your environment ever again, right? So make good use of this, and see you guys in the next video. Cheers.